At this point, we've gone over different algebraic tricks and we've looked at how to factor quadratics, but we haven't actually solved any problems that are quadratic in nature. So today we're going to look at how to solve a quadratic equation. And essentially, the idea is, suppose we have something like x squared plus x minus 6 equals 0. That's definitely a quadratic. And as far as it goes, when solving these, there's kind of certain steps we want to take to make sure to solve them. First thing we always do, as soon as we know it's quadratic, set it equal to 0. This one's already set to 0, so we're okay. But if you have an equation that's quadratic and it's not set to 0, bring everything to one side of the equation so it's equal to 0. From here, there's different tricks you can do. We're going to look at 2 of them for right now. The first one, since I just mentioned we've gone over factoring, try to factor this on the left, right here. And let's see, if I want to factor it, I need 2 terms. And I need 2 numbers that multiply to -6 that add to 1. That's a plus 3 and a minus 2. 3 minus 2 is 1. 3 times -2 is -6. So now I have it factored, and now I can actually use a trick. And the idea is, if we have 2 times x equals 0, then algebraically we know that means x equals 0. And by extension, if I have y times x equals 0, that means, well, if I have 2 things that multiply to 0, either the y equals 0 or the x equals 0. Because that's the only way I can multiply 2 things and get 0. And because of this, we get something that's really special in math. It's called the zero product property. Or you can also call it the cancellation law. Essentially, if you have a times b equals 0, then a equals 0 or b equals 0. And admittedly, that's incredibly simple and trivial. You've probably all known it since you were like in 2nd grade. But we actually use it here because once I factor this, now I have something, if you want, call it a, times something, if you want, call it b, which equals 0, which then tells me either a, which is x plus 3, has to equal 0, or b, which is x minus 2, has to equal 0. And now I have 2 different equations I can solve. Here, subtract the 3, we get x equals -3. Here, add the 2, we get x equals 2. And I get 2 solutions, -3 or +2. I'm not going to take the time to check these, but if you check them and plug them out, they'll work. And one thing I would actually point out as far as this goes, there's a rule that we'll learn later in the semester, but for right now, all that really matters, that's a quadratic equation. It's 2nd degree polynomial in math speak, and there's a rule that says whatever the degree of the polynomial is, that's how many solutions you get. In this case, that's quadratic, 2nd degree, degree 2, whatever you want to call it. We got 2 solutions, which is what we're supposed to get. So, we just want to kind of mess around with that a little bit more. Suppose we have x cubed minus x squared minus 6x equals 0. That's not quadratic anymore, but we remember factoring, and the first thing we look for when factoring is a common factor. There's a common x in all 3 terms. If I factor that out, then I'm left with x squared minus x minus 6 equals 0. Now I can factor this quadratic. The x will carry along. This will factor to x minus 3x plus 2 equals 0. And now I have 3 things. X minus 3, x plus 2 equals 0. And we can just apply the zero product property again. Either x plus 2 equals 0, or x minus 3 equals 0, or x equals 0. And then solve each of these. If x plus 2 equals 0, x equals -2. If x minus 3 equals 0, x equals 3. And if x equals 0, well, x equals 0. And now again, this was a third degree polynomial, it's x cubed, I should get 3 solutions. 1, 2, 3. So I got all the solutions that I want. So just make sure when you're solving these, you get the same number of solutions as the highest power of x. And understand that even if an equation is not quadratic, this is cubic, you only really know tricks in this class as of right now for solving linear and quadratic type equations, which means there'll be a way to manipulate the problem to solve it. And in this case, look for a common factor, which will then reduce your equation to a quadratic, and then you can solve it. So, suppose we have something like x squared minus 2x equals 6. I want to solve that. It's a quadratic. So we said the first thing you have to do for a quadratic is set it equal to 0. This isn't set to 0, so subtract the 6 to the left. We'll get x squared minus 2x minus 6 equals 0. And now solve that. The problem is, if I try to factor that, the only things that multiply to negative 6 are negative 6 and 1, 6 and negative 1, 3 and negative 2, or negative 3 and positive 2. And if I run down the list, none of those will give me a sum of negative 2, which means this can't be factored. And we need another trick to solve it. It's a trick I'm sure you've all seen before. It's called the quadratic formula. And all the formula says, if you have an equation of the form ax squared plus bx plus c equals 0, then your x has to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm sure you've all seen this before because you start seeing it in like middle school. Again, just remember from an exam perspective, I'm not going to give that to you, which means for solving quadratics, you have to know it. If you can't factor it, and some of the ones we solve won't be factorable, you have to remember the formula so you can actually solve them that way. But in this case then, all I really have to do is, the coefficient of x squared is a, the coefficient with the sign of x is b, the constant with the sign is c. And now I plug in, and I get, let's see, negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1. Now simplify that. This becomes negative 2, which is 2, plus or minus the square root of negative 2 squared is 4. Negative 4 times 1 times negative 6. The two negatives cancel, so it's positive, and then the 1 doesn't matter, so it's 6 times 4, 24. All over 2 times 1, which is 2. Which gives me 2 plus or minus the square root of 24 plus 4, which is 28, all over 2. As far as it goes, understand there are 2 solutions there because it's a quadratic. That is 2 plus the square root of 28 all over 2, and 2 minus the square root of 28 all over 2. If you want to write it in this form, that's kind of a more efficient way of writing it, that's fine. One thing to remember though, once you have radicals, if you can simplify the radical, you generally want to. And for the purposes of this class, we have to solve them that way. Meaning, we don't know the square root of 28. It's an irrational number. You can't just write it all out. So we try to rewrite the square root of 28 in simpler form. And if you all remember the trick, you try to find 2 numbers and multiply to 28 where you know the square root of one of them. In this case, 28 is 4 times 7. The square root of 4 is 2. So that's 2 root 7. And that's the simplified form of this. So this gives me 2 plus or minus 2 square root of 7 all over 2. That's fine. If you wanted to simplify even more, you could break this up as two fractions. 2 over 2 plus or minus 2 root 7 over 2. And then 2 over 2 is 1, plus or minus these 2's cancel, root 7. And that's the most simple form of that answer right there. At least for right now, I'm okay with us leaving them like that. But ultimately, by the time we get to the exam, we want to be able to do all the algebra out and simplify it down to this point. I think I have time to run through one more of these relatively quickly, just so we can see the quadratic formula. So suppose we have x squared plus 5x minus 2 equals 0. So really quickly, it's already set to 0. A is equal to 1, B is equal to 5, C is equal to negative 2. So when I plug into the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, which gives me negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 1, times c, which is negative 2, all over 2 times 1, which is 2. That gives me negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times 1 times negative 2. The two negatives cancel, so that's positive. 4 times 2 is 8, all over 2. Then I get negative 5 plus or minus the square root of 25 and 8, which is 33, all over 2. In this case, if I want to simplify that radical, the only two things that multiply to 33 are 11 and 3, and I don't know the square root of either of those, so just leave it like that. Now again, if you want to write your answer like this, that's completely fine. It's reduced, I can't simplify anything else, so I'm good. If you want to write it separately, you can write negative 5 over 2 plus or minus root 33 over 2. If you want to write negative 5 over 2 plus root 33 over 2, and negative 5 over 2 minus root 33 over 2, that works too. I'm not really particular about which way you write it. As long as you reduce it correctly, you can write it in different forms. I'm okay with that. Ultimately, when we are solving these, be aware from an ALEKS perspective and from an exam perspective. Sometimes you're told to find an exact solution. Sometimes you're told to approximate it and round it. A lot of times with applications, which we'll do later on in this chapter, we'll approximate our solutions. Just make sure when solving a problem, you solve the problem based off of whatever it asks for. If it says an exact solution, it means write something like this or this. Leave the radical in there. Mathematically, that's exact. If it says round it to 2 or 3 decimal places, throw that into your calculator, round off the decimal, and you're good to go.